So we are now passing a struct to this function. And this here would be an example for a use case where you could consider using a pointer instead of accepting the value. Because as you learned at the moment, since I am accepting the value here, this struct here will essentially be copied in memory when we call output user details, and the copy will be received in here. So for a brief moment, we'll have both the original struct here, which is one value in memory, and this received struct, which is a copy of that struct, but which occupies another place in memory. Now, to be honest, this is still a fairly trivial value, so using a pointer here is overkill and not really required. But for practice purposes, we can still change this function, and instead of wanting a value of type user, we can expect a value of type user pointer. So a pointer pointing at a user value in memory. Now, in order to get such a pointer, we then of course have to get the address of app user by adding this ampersand operator here, which, as you learned before in the course, gives us the address of this value in memory. And therefore, with this approach, we are now passing the pointer to this function. Hence, if we run this, we got the same result as before, as you'll see here, but now with pointers. But there's one thing that might look strange to you if you paid close attention in the pointers section. What could be strange in this code here, specifically in this line? Well, in the pointers section, you learned that if you got a pointer and you want to work with the value that's stored for that pointer and not with the address, that you have to dereference it by using *u, for example. That would then give you access to the value stored on that address. Just u, on the other hand, would be the address. So technically, we're trying to access first name, last name, and birth date on the address, not on the value stored at that address. However, this works because that's essentially a shortcut that's allowed by Go. The technically correct way would indeed be to dereference this, but in order to then use the dot on this, you would have to wrap it in parentheses, so that you try to access a field on the result of this dereferencing operation here, and you could then access first name like this. And that would be the technically correct way of accessing a field of a struct pointer. However, you pretty much always use this shorter approach, because it is allowed by Go, and it's shorter and nicer to read. Nonetheless, you should keep in mind that normally you need to dereference, but pointers to structs are simply an exception.